BKR chemistry classes, I had given some problems under Favorskii rearrangement for assignment. Let us solve them right now. So this problem corresponds to alpha alpha prime dihaloketone. So already we have seen if you have alpha alpha prime, that corresponds to quasi Favorskii rearrangement. Is it not? Quasi Favorskii rearrangement. So when I talk about quasi Favorskii rearrangement, I so when I talk about quasi Favorskii rearrangement, I know the product is alpha beta unsaturated ester. So as you can see in the products given below, all the four products are having alpha beta unsaturation. So you might have slight confusion. Okay, so we'll do a quick revision of the mechanism. So first step is formation of carbanion. The second step is intramolecular nucleophilic attack, then resulting in the elimination of Br to give you a cyclopropanone intermediate. So here we have the phenyl and methyl on one side and Br and H on the second side. Now attack of O-methoxide, that is methoxide ion, to the carbonyl carbon, resulting in the formation of tetrahedral intermediate. On one side I have bromine and hydrogen, the other side I have phenyl and methyl. Then, as already I've mentioned, whenever we have a quasi-Favorskii rearrangement, the next step will be in such a way so as to eliminate the Br out, resulting in the formation of alpha beta unsaturation. So this is the carbonyl carbon, the ester carbon. It is, this bond is broken, this bond is broken, so this carbon is attached to the CH carbon, which is having further, you have an unsaturation here, you got an unsaturation here, double bond which is attached to a carbon which has phenyl and methyl. So phenyl and methyl, check in the product. So you have phenyl methyl on the same carbon. See, the phenyl methyl will not rearrange. So this phenyl and methyl will not rearrange in Favorskii rearrangement. So based on that also, you can straight away go to the answer. So you cannot have separation of phenyl methyl from one carbon to the other carbon. So this is also wrong. This is also wrong. So straight away you can say A is the answer. But I have done the rearrangement mechanism, which clearly indicates that A is the product. It is alpha alpha prime dihalo ketone. So this rearrangement corresponds to quasi Favorskii, and we know that in quasi Favorskii we'll be getting alpha beta unsaturated ester. Is it not? So the first step, carbon formation, then intramolecular nucleophilic attack, formation of cyclopropanone intermediate, resulting in the cyclopropanone, then attack of the methoxide ion, then formation of tetrahedral intermediate, later removal of the Br. Okay, so what we get is alpha beta unsaturated ester. Okay, so this is not an ester, this is not an ester, this is having no alpha beta unsaturation. So A is wrong, B is wrong, D is wrong, and you can see in the C option you have alpha beta unsaturation. So C is the right answer. The next problem comes from Jan 2019. It corresponds to cyclic haloketones. I have also given videos for cyclic haloketones. If you have any doubts, you can go through that. So here they have given a mechanism whereby they're given a labeled carbon. So the product has labeled carbon, and depending upon the mechanism, we have to sort out which is the correct labeling. Okay, let us do the mechanism quickly. So let us take the starting material, which is alpha haloketone. As we know, the first step is formation of carbanion. Then you have intramolecular nucleophilic attack, resulting in the formation of cyclopropanone. So now this particular carbon is labeled. So we'll label this particular carbon. Then you will attack of the OET minus, that is ethoxide ion, resulting in the formation of tetrahedral intermediate. O minus, O ethyl. Next step, you all know it very clearly. So when the O minus reverts, We'll be having the cleavage of the ring. So here the either side cleavage is equally probable because it is a symmetrical system. We should not forget writing the labeled carbon because the product requires the labeling. So I cleave on this side or I cleave on this side. Both are possible. So let us take this as A cleavage, this as B cleavage. Let us see what happens when I get A cleavage. So on A cleavage, so if this is a cleavage, so this carbon will be attached to this side of the ring. So I'll be having COOET. It will be attached to this part of the ring, this part of the ring. Is it not? So I'll be having the formation of product like this. And don't forget to label the carbon, and this carbon is labeled. Now I go with the B scheme. So when I go with the B scheme, I can see I have this particular cleavage. So this is the cleavage. So this carbon is entitled to this particular attachment of to this particular carbon. So I'll be having COOET attached to this carbon, and this is the ring. So I'll be having carbon. Then again label it. So what I can say is that I have labeling in the carbon adjacent to the ester carbon and the next to next carbon. So that is how the product is. So it is not the ester carbon, it is the adjacent carbon, that is adjacent carbon and next to next carbon. You can so now you can see this is the ester carbon which has the labeling, so it is wrong. So option A is wrong. Then I cannot have a six-membered cyclic ring, therefore this is also wrong. In C you can see this is the ester carbon and you have the adjacent carbon which is labeled an ester carbon and you have the adjacent to adjacent carbon. So option C is the right answer. Here ester carbon is labeled, so it's wrong. So option C is the right answer. So as we know the Favorskii mechanism, so first step is formation of carbanion. So you'll be having the formation of carbanion, then you'll be having intramolecular nucleophilic attack, relieving the Br to give you a cyclopropanone intermediate. So I'm sure that you people know the mechanism now in detail. Okay. So next step will be the O-methoxide attack of O-methoxide, resulting in the formation of a tetrahedral intermediate. So maybe I'll write it upside down so that it becomes clear. O minus OMe. Then when this O minus reverts, and when this O minus reverts, the cleavage will be such a way that to give a stable carbanion. So this will be the cleavage giving us carbanion which is stabilized by the resonance from the benzene ring. So I'll be having a carbanion formation in this carbon because it will be stabilized by the phenyl ring. So so I have the formation of product like this. So I'll be having the carbon with the carbanion formation followed by a CH2 which is attached to the ester group. Okay. Now they have given hydrolysis. So we have proton source and hydrolysis. So what will happen? I'll be having the formation of the CH methyl and I have the ester. Ester will be hydrolyzed to an acid. And as you can see, they've given polyphosphoric acid. And we know that polyphosphoric acid has been used for the cyclization with the aromatic system. So, in a simple terms, not exactly in mechanistic view, I can say that I have the removal of water to give you the product, which is so I have the first carbon attached to methyl, which is a CH carbon. Then I have a CH2. Then I have a C double bond O. Now it has been attached to the benzene ring. So I have a five-membered ring generated and I have a methyl here. So I can see the product, the methyl, the para carbon has a methyl. So methyl, the para carbon does not have methyl, so this is wrong. The methyl para carbon does not have a methyl, so it's wrong. So this methyl, the para carbon containing ring has a methyl, so this may be the product or the methyl, the para position, the ring has the methyl, that can be also the product. Now we can see that here the product has a CH methyl followed by CH2 then C double bond O. So this is wrong. So option A is wrong, option B is wrong, option D is wrong. So option C is the right answer. So you have got three reagents here. So sodium methoxide, Favorskii rearrangement typical, then hydrolysis, which hydrolysis the ester to acid, and also you have the carbanion generated will be converted to CH. Then you have polyphosphoric acid. This polyphosphoric acid does the cyclization step. So we have finished all the four reactions. So Favorskii rearrangement, all the corresponding reactions we have covered in this particular video. So if you have any more doubts, you can always post that in the comment section. And if you want me to teach any other topic, that can also be posted in the comment section. See you all in the next video. Kindly like, share, and subscribe the video. Thank you so much.